Oh, but it worked. Okay. Word problem. Don't worry, it's going right there. It's all the only place it's going. So, I've given you one like this before. The only difference now is there's two pieces of information there, so you need two different inequalities. And both of those inequalities are going to go on the same graph. That's why we call it a system. Okay? So I don't know, 10 to 15% of your test is going to be this. Okay? Well, the whole test is inequalities. Word problems, recognizing the equations, that kind of thing, okay? So, what's the first piece of information? Do we care about the first sentence? Not really. That's just kind of putting it in terms that maybe you understand. And I get that all the time. It's like, what is this thing? Someone said, in physics, I said a bludgeon comes this way at this angle, hits this, and it goes off in that angle. Someone needed to know what a bludgeon was before they could do the question. I'm like, well, who cares? Cross it out and write ball. Oh, okay. Then they could do it. And it's like, I don't know. Exactly. Any excuse to not do it. That's right. At most. What does that wording mean? We're doing inequalities. So could it include 20? Sure. Could it be 10? Does that work? Is that okay? You understand that wording? 20 coffees are needed, blah, blah, blah. I'm not going to say here, like a first example, pick a couple of nice variables, right? Define the variables. What do you want? What do we got here? Well, we have lattes and cappuccinos. What are a couple of nice variables? L and C works for me. So let number of lattes be L. Let number of cappuccinos be C. Okay, I need at most 20 coffee. Could be 20, could be less than that. So that means the number of lattes and the number of cappuccinos. What do I want here? Less than or equal to 20. Yeah, that's what that says. So take the English, make it math. Does that make sense? Uh-huh. Okay, so that's the first piece of information. 20 at most coffees are needed. Here's the next bit. At least twice as many lattes to cappuccinos. And this one's a little trickier. Because if you write it down, I'm going to write it down wrong, okay? So don't copy this. If you write it down like as it looks, twice as many lattes as cappuccinos, it's wrong. Okay? The reason is if I say I got 2 cappuccinos, all right? Then how many lattes do I have? Well, divide that by 2 and L is 1. Does that make any sense? Like, it doesn't make sense because I need twice as many lattes as cappuccinos, right? Not twice as many cappuccinos as lattes. So I'm showing you what not to do. What you need to do is this. Okay, lattes, twice as many lattes, at least. What does that mean, at least? Okay, so now that I wrote it down, let me explain it again. If I've got 5 cappuccinos, because C is the number of cappuccinos, right? Then what do I have for lattes here? Yeah, Yeah, does that work? Is that what this says? Yeah, okay. So I know it looks opposite, it looks backwards. That's what you got to do. All right? Twice as many lattes as cappuccinos. So in math, you have to write it like that. Whatever cappuccinos is, the lattes is double. But at least, it could be more than double, right? That's the words at least. Okay? So for example, if I had 2 cappuccinos, could I have 10 lattes? Could I have 15 lattes? Is that greater than or equal to 2 times 2? Still works, right? Okay, so you got to maybe play around with it a bit. So I know it's tricky, but okay, that's what you got to do. Graph. Provide a reasonable solution. So there's my 2 equations. Is this all real? Think about it, the context of the question. Can you have half a coffee? No. It's a whole coffee. Either you get 1 coffee, 2 coffees. Could you have 0? Sure. All right. So I don't want real. What's a good letter to have here? Whole. Okay. I could have natural, but you know what? Maybe. But I could have 0 cappuccinos and come back with 20 lattes. That would still make sense here, wouldn't it? Yeah. So I don't want natural. Whole numbers make sense here. Okay. So L and C are the set of whole numbers. So to graph this, it doesn't matter which goes where, but the point is I don't want any negative stuff here. It's whole numbers. Doesn't make any sense to have negative coffee. So let's put cappuccino there. Let's put latte there. Okay, and then how many lattes could I possibly get? What's the maximum number of lattes? 20. Yeah, I could have 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you don't have to do this, but since I got graph paper, why the heck not? How many cappuccinos could I get maximum? Could I get 20? That works here, but it doesn't work here. I have to have at least twice as many lattes as cappuccinos. So I can have only 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Let's move that. So I'm just going to put a line from that point to this point. Is it a solid line or dashed? Solid. That's terrible. Better. Okay? That's it. Like, could I get 0 and 0? Sure, but nobody would be very happy. But according to this, I guess it's part of the solution. Okay? Could I get, I don't know, 1, 2, 3 lattes and 10 cappuccinos? No. But I could get 3 lattes and 1 cappuccino. Okay? Could I get 3 and 2? No. Okay, now I'm not going to go and actually pick every single point in here, but there's some points that work and there's some that don't. Okay? For wherever this is 20, that's 10. So if this thing's 10, I could only have 5 here, right? So there's actually a kind of line like that, where this is my solution area. So make your sandbox however you do it, okay? But these don't really make any sense. That's not fitting this equation here. So my solution area is just going to be that. So lastly, pick a reasonable solution. And did you need to graph this whole thing to come up with this? No. What's a reasonable solution for this person going on a coffee run? I don't know, 15 lattes, 5 cappuccinos. Does that work? Is it reasonable? Sure. It's 20, and I got at least twice as many lattes as cappuccinos. Okay, could I get 12 lattes and, I don't know, 4 cappuccinos? Sure. Maybe a couple people will be upset, but it still works. Okay, it's only 16, it's not 20, but it says at most 20. So whatever, maybe they sold out. That's how it is. First come, first serve, right? Okay? So there's lots of choices here. It just says provide a reasonable solution. There's a couple. There's others. As long as this, you don't, what's the word here? And not go against, but not conflict. I can't think of the word. Anyway, it's got to work here and it's got to work there. Okay?
Contradict.
Contradict. Thank you. New start with a C. All right. So that's it. Page 317, 6, 8. Let's just do those. And then I just want you to go back. I should have assigned these ones earlier. 304, 8, and 10. Just look at the equations. Those aren't systems. Those were just one equation. Okay, so go back and just look at the equations. Get familiar with those. Also, not more questions. Just see page 322 for more examples, okay? Cassidy, go sit somewhere else, please. Okay? It's helpful. There's 3 more examples on 322 to just match up the wording with some equations, okay? Now, having said that, I'm going to hand back to quizzes.